business logic. So that's the main idea of this talk. And I'm planning to give an outline of what is R and what are the basic data types in R which is used to support exploratory data analysis. I will be dealing with descriptive data analysis, visualization, and clustering. And I will also share some of the R resources that we have to support exploratory data analysis and machine learning. So here is a brief introduction of exploratory data analysis. So it is, as I mentioned, it is used to play with the data to get to know about it in detail. So begin with some initial hypothesis or some initial assumptions. Now once we get to know about or we get a feel of the characteristics of data better, then I think we would be able to take a better decision on what business logic should be applied. So most of the time people are jumping onto machine learning tasks such as clustering and classification, but it may be an absurdity. Without getting to know about the data, its characteristics and its flavor, it's not possible to derive or jump into a conclusion. So visualization and graphical based systems help us to play with the data, get to see the data, get to visualize the data, what are the characteristics of data, and what are the properties of the distribution. So this helps a statistician to have some initial assumption or initial hypothesis and then test the hypothesis for its validity. So much before modeling and predictive analysis, and very much before machine learning, this exploratory data analysis, or EDA as it is often called, it is an important tool in the data scientist toolbox. So we are going to see a very powerful language, which is R, that is used for statistical data analysis and visualization. So when we talk about R is not only a language but also an environment for inferring statistical information. So R was originally the GNU S. It is originally the GNU S. S is an original MIT-based language, which is also related to Scheme, much similar to Scheme, and the syntax that we are following in Python now. So its GNU version is called R. So R was developed by a core team that was headed by a data scientist from New Zealand. The university is a professor in the University of Auckland. It's called Ross Ihaka, and a Canadian bioinformatician called Robert Gentleman. So these two led the team, the R core team that developed the R programming language. So it was initially what do you call, command line system without any GUI, and it was a very powerful system for good development of statistical applications. And its main advantage is that it is open source and it can be run across a variety of platforms. It is cross-platform. So as I mentioned before, it was originally developed as a lean tool, meaning that it is not functionally that much heavy. It only supports the basic command line operations. But now it has also a GUI coming along with it, which is called the R Studio. But anyway, we are using only command line operations for basics. And then once we have a grasp of the basics, then I think we can easily learn about or I can easily play with R Studio. And the strength of R is that the original package is very lean or very lightweight, and it has a repository of additional packages to extend the functionality. And all these packages are maintained in the FTP servers of the CRAN, or the Comprehensive R Archive Network, as it is called, CRAN, Comprehensive R Archive Network. So it supports various statistical and graphical packages. Over 6,700 packages are currently available, and every year releases are getting updated, or annual releases are coming, bug fixes are releasing. So it's a very active and vibrant community that is working around this R team. So basically R help and R development, it's short form for R development. There are mailing lists for this R help, and also Stack Overflow is providing a very strong support for R aspirants. Basically, I've taken all the information from the CRAN project site, which is cran.rproject.org. It is a source for the contents which I'm listing in the slide. So you can go to this website and get all the information related to R. So it's installed in Windows as a precombined binary distribution, and in Linux and other flavors of Linux, it can be installed using the aptitude repository sudo apt-get install R base core. R base core is a core version. It's a main engine, R development engine. And for those who are coding gurus, we can use the R-based development environment also. R-based development that supports us to write our own packages and then compile the R scripts and build a package of your own, so that you can publish it to the comprehensive R archive network. Others can work on your code, and they can promote your code also. So these kind of things are available because it's an open source community. So it's distributed now as a GNU General Public License tool. You can distribute the code freely, which means you have to share the source code. That's very important. Now, I'll be devoting the first say 15 or 20 minutes for discussing the basic data types in R. After that, I will move on to descriptive data analysis and visualization. So you might be, most of you might be knowing R, but anyway, I will have a brief walkthrough the basic data types in R. So we have 4 basic types which are supported. These are the vectors, the lists, the matrix vectors and lists, then matrices, factors, and then data frames. So we're going to see one by one, just a brief walkthrough, that's it. So basically in R, a variable, anything is an object. That's the first thing you should understand. Anything you write is an object. Any variable you write is an object. So the basic R commands are assignment statements or expressions. There are only assignment statements or expressions in R. Whatever command you type in, it will be an assignment statement or an expression. So if you are creating an object, then these objects will be saved in a workspace, and this workspace can be you can save the workspace in your hard disk for later retrieval. So as I mentioned, anything is an assignment or expression. So expression is automatically evaluated and printed. So you don't need to do a separate printf command as in C, like as you give printf C, or in Java as you give system.out.println. So that kind of statements are not required. It's automatically printed. So for example, I'm using this left arrow operator. This left arrow operator. This is called arrow operator. That's the assignment operator used in R. So an assignment evaluates the expression and saves the value to a variable, but it is not printed. So for printing that, you have to type the variable name. Example I will show. So is this command terminal visible? Hope it is visible. The terminal is visible to everyone. By typing, yeah. So I typed capital R. I will type once again. I will type capital R. So when I type capital R, it is going on to the R prompt. So it is showing the version now 3.4.1. It's not the latest version, but still it's a stable version which I prefer for 32-bit. That's why I installed 3.4.1. So it is the latest in my system. So that shows the versioning information and some other related to the R project. And then anything I can do, or the simplest thing I can do, is to assign a value to a variable. For example, I could write X assignment operator. So this is the left arrow. You can type the left arrow using the less than symbol in the keyboard, and then put a hyphen. That will be the arrow, left arrow. So X left arrow 3. No need to put semicolon and all. You can simply press enter. So now 3 is assigned to the variable X. So now X is an object. Okay. So now if I type X, simply if I type X, no need of printf and all. If I just type X and press enter and see the value of the variable X, which is 3. So if you are familiar with MATLAB, then you might be appreciating this syntax, isn't it? MATLAB has a very similar kind of syntax. Basically, this is a syntax that was used in the scheme programming language by MIT. It is a functional programming language developed by the MIT, Massachusetts Institute of Technology. It was used in earlier days when Fortran and all was basically used for business logic. So nowadays, the entire thing has been rewritten using C programming. But anyway, the syntax follows the same functional-oriented paradigm. So now 3 is printed. So that's the simplest assignment statement that you can give. And if I want, so it's automatically typecasted. So now 3 is a number, right? It's a numeric. So if I type class class. Class is a command which is used to display the data type of a variable. So here we don't need to explicitly mention the data type. For example, in C and all, you need to type int x, isn't it? Index or char C or float D. So like that, here it is not needed. It's automatically typecast. So when I type x is 3, and if I type class of 3, see what, not class of 3, class of x, see what happens, it's printing numeric. So it's automatically recognizing that x is a variable of type number or numeric. This is the idea. So that's the simplest assignment statement which I have written. And you could also write in the traditional C programming way that x is equal to 3. That's also equally possible. If I write x equal to 3 or say y equal to 3, that's also possible. It won't show you an error. It will still work, but it is not a typical R programming way. It's a C style of writing. That's why I used left arrow or assignment operator. And as I mentioned, the class of the variable can be used to determine the data type of x. And now we can also ask questions. It's very similar to literal programming, or it's very similar to functional paradigm, that you can ask questions like is.numeric of x. So is.numeric of x, just like asking is x a number? So we can try this command, is.numeric of x. If I ask this question, then it will say true, yes, it's a number. Similarly, you can ask is.character of x. Let's say false, no, so it's not character. So then I can also convert from integer to character and vice versa. For that, you have to use as. So in English, we say as. It is as beautiful as. So like that, we can use as dot character. So it will automatically convert that into character. Let us see as dot character. Let us see what happens. As dot character of x. Then let us see what happens. See now, the character x is displayed as double quotes 3. See the difference? Earlier it was single 3 or number 3, but now it is displayed as double quote 3. But there is a small, it's a subtle caveat here. If you once again ask is.character of x, so false, which means that it has not been completely transformed into character. Even though we gave the command as.character, it is displaying as 3, character 3, and not number 3. But still, internally it is stored as a data type integer. You can test that. Is.numeric of x, if I give, will give true. So internally it is still numeric. Because, why? Because the original variable x in the workspace is still a number. So for that, you have to assign it back to x. That is, you have to write like this. X is assigned to as.character. If you simply give as.character, it will print as if it is a character. But internally, it is still a number. So if you want to change the internal type also, then you have to assign it back. Assign the as.character return type back to x. Now, x is assigned the character value. Now, if you print x, it will show 3. And now, if you show is.character, if you issue is.character, you can see that now it has converted to character. True, it is showing true. Because now we have assigned it back. That's right. Sorry, following? Now, similarly, we can have basic other data types like integer, logical, character, all those things. So logical means a vector of Boolean, true or false. And we have just seen the Boolean logic, right? Is.character returns true or false. So it is a Boolean, or it's a bool type return type. So it's a logical return type. Similarly, if you want to store real numbers, you can have numeric, and if you want to store integers, signed integers, you can have integer data type. Character is the variable character, or varchar, you can say varchar. So all these are variables. But now let's move one step further. We'll move on to vectors. Now, what if I want to create a number or a sequence of characters? If I want to create a sequence of characters, say for example, I want to create a, an array. So in C, this corresponds to your array. I want to create an array of numbers, say 10, 20, 30, and 40. What will you do? So for that, you can use the operator called C parenthesis. C stands for concatenate. Basically, you are doing concatenation operation, right? Basically, you are doing concatenation. So you are concatenating, first you are creating an integer 10, then you are concatenating 20, then concatenating 30, then 40. So likewise, you are actually doing concatenation only. So that's the basic idea. So for example, I can concatenate 20 to 10. For example, I can give A is assigned C. You can concatenate 10. Concatenation is with the help of a comma. So 10, comma, 20, comma, 30, comma, 40. So I'm concatenating 20 to 10. And now it has become 10, 20. Now I'm concatenating 30 to 10 and 20. It has become 10, 20, 30. Now I'm concatenating 40 to 10, 20 and 30. So likewise, it is working. It is repeatedly concatenating. So C is basically a concatenation operation. It's repeatedly concatenating to derive a vector. So it's a derived data type. As you can imagine, it's a derived data type. So if I type A, now it is showing 10, 20, 30, 40. So it is used as if it is a base type or built-in type, but in fact, it is actually derived from numbers only. But in R, it is often available as a base type because we can directly create a vector using C. We don't need to do concatenation. So this is how we can create vectors. And we can use functions like finding the length of the vector, sum of elements of the vector, all those things we can do. For example, I will show sum of A. Simply if you type sum of A, it will show you 100, meaning that it is taking the sum of the elements of the vector A. You can also issue length of A. Show you 4 because the vector A has 4 elements, namely 10, 20, 30 and 40. This is the idea. And you can also create a character vector. Say for example, countries, the vector countries, India, Japan, USA. So I have created a character vector, and if I type countries, you can see that this vector has quotes. Each element is quoted, double quoted, which means that the elements are characters or strings, sequence of characters or strings. So this is a character vector. And the interesting property is that we can use subsetting. We can use subsetting just like we use what do you call AFI. So in C we use AFI, right? AFI. For example, AF1 in C. If you type AF1, you'll get the first element of the array. Is it like this? We can also issue AF1 in R. So if I type AF1, it will give you 10 because the first element of the vector A is 10. Similarly, if I type countries of 1, countries of 2, if I type countries of 2, I will get Japan. And mind you that it indices the index starts at 1 and not 0. So in C, the index starts at 0, right? For I equal to 0, I less than n, like that it goes. When you store n elements, actually the array index starts at 0, but in R it starts at 1. That is why when I issued 2, you get to get the element Japan and not as you expected US. So this is the idea. So you can concatenate like this also. These are all about vectors, and then an interesting property of repeated vectors. For example, this is very interesting. For example, I want to get consecutive integers from 1 to 10. I want to create a vector 1, 2, 3, 4, 5, 6, 7, 8, and 10. One thing you can obviously do is numbers is equal to C. I can type 1, 2, 3, like that you can type. But there is a very easy way to do this. So there's a shortcut to do this. Just like in C, we use plus equal to. For example, I equal I plus 1. You do I plus plus. So like that, there is a shortcut to do in R. That is numbers is equal to 1 colon 4. So 1 colon 4 or 1 colon say 5. So now numbers is assigned the first 5 numbers automatically. So this colon indicates that we are requesting for a contiguous or consecutive set of numbers. So here all numbers from 1 to 5 are included. But if I want to include selective numbers like 10, 20, 30, I have to use the C operator. There is no other way. But when I want to create a continuous set of elements or continuous sequence of elements, I can use the colon operator. I can use the colon symbol to create a continuous set. And then I can also use repeat to get a repetition of the vector. So for example, rep numbers comma 3. If I give rep stands for repeat. So if I give repeat or rep numbers comma 3, see what has happened? The vector numbers is triplicated, or it is repeated 3 times. So whatever number we are giving after this vector, that many times the vector will be repeated. So for example, I have created a vector named numbers. I have asked to repeat 3 times, so that vector 1, 2, 3, 4, 5 is repeated, simply repeated 3 times. And this is a new vector. The new vector has length 3 times the length of the original vector. If I issue length of, or I should assign it, I should assign this vector, say for example, q equal to repeat numbers comma 3. So q is now 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And if I issue length of q, I'll get 15 because it is 3 times the length of the original vector. That's repeated. But now just imagine if I have to create a vector like this 1, 1, 2, 2, 3, 3, 4, 4. What will I do? So here the individual elements are repeated. So for that I have to write like this: repeat numbers comma, instead of 3 I will write each equal to 2. So if I give each equal to 2, then I will get 1, 1, 2. So each element is repeated. So if I simply write a number, the entire vector is repeated 3 times. But if you write each, so you can get all these attributes and these keywords